First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of two experts.
I realized I was an expert on this subject when I was
Whom I will not
seven.
teach today.
7
7
years old.
I see.
I
On
was
your Commodore
working
64?
On my Commodore 64.
There's a song to
There's
go with
a there's a little demo program in there that bounces a ball around the screen.
Mm-hmm.
Yep.
Did you hack it so that the ball emitted particles and such?
No, but in the demo,
Expert.
you have to basically type the basic program in when you turn on the computer.
Uh-huh.
And then run it.
Uh-huh.
Okay. So in their demo, if you're like 7 years old and you can barely read and write, the last thing you want to do is type a whole bunch of extra letters.
Right.
So the motivation to make the program shorter was very high.
Mm-hmm.
Because you had to type it in every time you wanted to mess with it, right?
Mm-hmm.
So I was highly motivated to make a more efficient version.
Mm-hmm.
And I improved on it from the example that was given in the official book, whatever.
I see.
And I made it much, much shorter. And then I achieved enlightenment.
I see. You're a little monk Whisker.
Right.
Did you shave your head too?
Some years, yeah. Yeah.
Do all little kids shave their heads?
In the summertime. It's hot, you know.
I'm trying to think. I don't think I've ever shaved my head.
It doesn't necessarily help you program unless you don't have air conditioning, which we didn't.
I think I tried shaving my chin because I saw my uncle do it once.
This week.
Yes, it is true.
Well, technically,
2 weeks ago.
It was 3 weeks ago.
3 weeks ago. Yes, 3 weeks
Bryce
ago.
time traveling right now.
We're
not going to get into it. Yeah.
All right, kids. Unless you actually have hair, do not shave your chins. Girls, do not shave your chins. It leads to blood. Uncomfortable.
So,
how did we get off on this
life
tangent?
lessons. Because Whisker said something about heads.
I didn't.
First Spin has turned into First Psych.
First psych. What do you mean first psych?
Psychology lessons from Addie.
Right. All right, anyway. Go ahead.
Okay,
Continue.
if you're done being a weirdo.
I was just giving lessons.
Well, I'm trying to give you a lesson here.
Oh, that's great, because you were talking about being a little kid.
Yes, and you're you have about as much experience with code as I did a year later than that. So, you know.
Screw you.
So I don't know. I think this story might be appropriate for you. All right. So basically last week we were talking about the text demo and text VGA on a propeller BOE or demo board or whatever you're going to plug it into. Mm-hmm. And Addie was learning how she could very easily, use it to print text out onto a text mode on VGA monitor.
Mm-hmm.
So it's very similar on the Commodore 64. You could put characters wherever you wanted on the screen, right?
Okay.
And that's basically what I did with the ball. It was just text mode, and I would print a ball extended character onto the screen where I wanted the ball to be for that iteration, right?
Yep.
And I would print an empty spot where the ball used to be last iteration.
Mm-hmm.
Make sense?
Mm-hmm.
Mm-hmm.
So with this, you can create animations in text mode.
Right.
Mm-hmm. What's an empty character, though?
Just a
space.
Space?
Yeah.
Okay.
Yeah, there's that.
Okay.
So with spaces and that, or you could use, change the color in this spot and then change it back.
Okay.
You could have a block of background color moving around the screen.
Mm-hmm.
Any number of things you could do. You could leave, if you don't turn it into a space when you move past it, you create a trail where you've been.
Mm-hmm. Oh, like Snake.
Yeah. If you keep a queue of the last 12 places that you've been in and erase the 13th one,
that's super
then your
Snake.
snake has a tail and a head, right?
Right.
So these are just some basic tips I wanted to share with you. But when you're bouncing a ball around the screen, basically you're trying to detect the edges. And when you detect the edges, you want to reverse the direction, right?
Mm-hmm.
So if you're moving down and you hit the bottom of the screen, you want to reverse your direction to move back up.
Mm-hmm.
Now, the
But
way
then-
that the original program did it was by using some for next loops, and it for nexted itself down, for nexted itself up,
Okay.
you know, and it had to do checks onto where it was on the screen.
Okay.
I changed it so that it used a modifier on and a variable to store its x.
Right.
So it uses an x variable and then it uses an x modifier variable, and that modifier variable can be 1 or it could be -1.
Okay.
And then when it passes the top or the bottom, you just multiply the modifier by -1. This is pretty impressive math for a 6-year-old. And it flips the polarity of the modifier. And then it
Right.
turns around direction, and you don't need two different if-then statements to check if you're on the top or if you're on the bottom. Because the math doesn't care if you hit the top or the bottom, you're just out of bounds.
Okay.
Right.
So you can do
the
something
same
like-
thing for the side, the left and right too.
If y is less than 1 or greater than, how wide was our screen on this?
32.
31. So if it's less than 1 or greater than 31, then x mod equals x mod times -1. Now we're gonna
Okay.
turn around.
Okay.
Right? And you would actually use less than 1 or greater than 30 because the 31st character is the edge
Okay.
of the screen.
Mm-hmm.
So it's starting from 0, like most programmers do.
I see.
Okay, so if you want Pac-Man, what do? You go out one side of the screen, you modulo in the other side.
Yep.
Yeah.
So you want to be able to support that kind of thing. You know,
Do-
we're just getting
do
into
I?
I'm just giving you the tricks that they used to use in all the old arcade stuff.
Yeah.
In fact, Pac-Man is
no.
not made up of drawing graphic lines or anything like that. It's actually a bunch of pre-made characters that look like all the different pieces.
Right.
So like Pac-Man is made up usually of 4 characters, maybe 6 characters
Yeah.
that make the shape of Pac-Man, and then it changes characters to make his mouth open and close.
Right.
Right? And then the ghosts are similar. There's a set of characters that look like the ghost.
Right.
And then they change the characters out for the eyes to make them look the different directions, up, down, right, and left. And there's a character for the dots and a characters for all the little blue lines that make up all the borders.
Mm-hmm.
And so when they draw Pac-Man, they're drawing a big character display.
Yeah, it's just text
with all
mode, just like what you're doing.
They call it. They typically call it tile driver mode
Okay.
because it's a bunch of character tiles with custom graphics on each tile. right,
Mark
to
van de
make it look
Wettering
like-
used this trick with his satellite Arduino tracker.
Satduino?
Yeah, he generated a custom.
Or no, wait, he called it angst.
He would call it angst.
It
He's an angsty
was
kind of guy.
Arduino and GameDuino satellite tracker.
Yeah. So he made the satellite tracker, but he needed to show where the satellites were on the globe.
Correct.
So he needed to create a map, but the Arduino didn't have enough memory left after all of his crazy satellite tracking code to be able to, display a graphics mode.
Mm-hmm.
So instead, he used a custom character set,
Mm-hmm.
and the
Right.
characters were different parts of the coasts.
Right.
Oh,
to
interesting.
draw out the satellite, the world map.
Yeah, which is a really cool trick, and he actually
Mhm.
created some fancy programs to generate that thing from scratch, some fuzzy math and fractal logic and all that sort of cool stuff.
So anyway, a lot of the old arcade games work that way. They just have character sets that are all the graphics for the game, and then they just draw them in the appropriate places to create the display on the screen.
Okay. So,
Roy kind of makes games for a living, so he knows about this stuff too.
right.
Yeah.
So I kind of want to make a game,
Uh-huh.
and I'm trying to make it like a Tamagotchi.
Oh, okay.
Yeah. And I wanted
Little
to use
computer pet.
Yeah. It'd be
So
super
propeller
cool.
pet.
Yes. Yes. I haven't quite figured out. Prop pet? Pro pet?
Propagotchi.
Pravagotchi. Oh, that sounds strange. I'm still working on the name.
Pet Peller.
Pet Peller. Pet BOE.
Bogotchi. BOE gotcha.
Bo pet bow. Anyway, so I'm trying to. Okay, so first we got to think of a name, but I'm trying to figure out. Like it'd be well, I think I want it within bounds, right? I don't want it to go modulo all over the place because like if it's like one arm is like on one side of the screen and his other arm is on the other side of the screen, I think it'd be awkward.
Well,
Right?
but you could have it go completely off the screen and then come on the other side after it's gone completely off one side if you wanted.
Yeah, nah.
There's ways to do that.
Because what if it like does
the
this
virtualized space that you have it exist in can be much larger than the actual screen space.
No, but I can't.
No, I'm saying that in the code it can because
Yeah.
it's just an XY offset to
But-
where it's at, right?
My main thing is if it does its business.
I'm not trying to help you design your game. I'm correlating with what Roy was saying that because you're just talking about an XY axis, the actual way that you'd approach this, it doesn't matter.
Okay. So like how do you I don't know, how do you keep them all in one like character set? Or I mean, how do you
Well,
keep
you're
it-
going to be
keep
using the
little thing all in
existing
one?
character set that's built into the prop, right?
Yes.
Right. So all you're going to have is like a little data table that says, I want these set of characters put together to make one little creature, and I want this other set of characters to be another creature, and then you'll just have functions that draw those at different places on the screen, right?
And when I do that in like DAT in the DAT section that I put that in,
you probably have a DAT section where it would list out the different little strings of
Faces.
characters
Yeah.
that are all your little faces or all your little creatures or whatever you want to call them, right?
Your
Uh,
And you could have
states.
different states for happy and sad or hungry or whatever. And so you would just you would have to like experiment with different looks and put them into a data table at the bottom. And then later, up at the top, you can just draw each one of those things wherever they happen to be in your little screen world.
Now there was this really neat demo that I think Chip had made, and it showed like a whole bunch of it showed like boxes and buttons and text and different colors and lines.
You're sure Chip made that? Might have been somebody else there.
Well, there was a scroll. No, I'm pretty sure it was him. There's a scrolling, like diagonal mouse-looking thing that looked like a propeller beanie.
Okay.
Does that sound familiar?
No. Sorry.
That's okay. And the DAT section was ASCII art, like the kind that people would copy and paste to spam in chat rooms, like of a propeller beanie.
Okay.
I'm trying to see if I can figure. Maybe it's high-res text. VGA high-res text. I don't know if you have the OBX open.
Well, there's that particular one is also in the
Comes with
library
PropTool,
demos.
yeah.
Okay, so let me try and see if it's in there. VGA high-res demo. Ah, dang. That's not it.
Doesn't look like it.
No. All right. Well, I'll have to keep.
It could be one of the tile driver demos.
Let me look.
I don't
Anyway.
know. Yeah, there's in tile driver demo 2 and 3. So there's VGA tile driver demo 2 and VGA tile driver demo 3. There's a little propeller beanie drawn out with ones and zeros in the bottom of them.
Yeah, let me take a look here and see if I can find it. I'm looking at tile driver.
VGA
tile driver demo 2.
Uh-huh.
Yeah, that's it.
Right.
So
So that's like a little graphic. That's using a tile driver though, so it's not using the built-in font. It's making up its own,
okay.
right?
So I wouldn't have to do something like that.
You don't have to do this. This is a little bit more complicated because you actually
I
have
would
to
say
draw.
start with the existing tile set that the character set that's on the prop, and
Mhm.
get comfortable with using it and the
And
limitations
moving it around.
and moving it around and doing your bounding of your edges and
Yeah.
using your offsets and erasing where you used to be and all that sort of thing. Solve all those problems first without complicating things with your own custom set.
Okay.
Right. And we can update it later to one that uses custom graphics and make it look better, right? But you can figure out all your logic and gameplay and everything using just the built-in characters.
And can I ask, how complex can the graphics be?
I wouldn't really focus on making the graphics complex. You've got
Well,
200
I'm just wondering in general.
200 and some characters, different characters in
Mhm.
that character set that are like visible, displayable characters.
Yeah.
And within that, you can draw a lot of stuff. I mean, you've seen what's
Right.
possible with ASCII art, right? You can draw a lot of stuff with those. So I would focus on those and just sort of learning how to use them together to make things look in a cool, cute way that you want them to. But I would focus your energy more on making your game do cool stuff that you want it to do.
Right.
Okay.
Because that's the real fun part, is the gameplay stuff.
Yeah. Well, I gotta try and figure out. Maybe I'll just make the faces and see how to access them, because I don't think I've ever really worked with the DAT section before. In like, getting them from.
Fun part about this, I think, is that instead of using like a keyboard and mouse to interact with it, you can actually have a physical thing, because you've got
a
like
position switch.
Well, I was thinking more like you've got your accelerometers, you've got your compass, you've got all this sort of thing, and
Mhm.
you've got your XPs. You could actually be interacting with your pet thing on your screen with a second prop BOE sensor package. So it could detect when you pick it up, when you move it left, when you move it right,
Mhm.
how much light there was, if there was a human in front of it, it could detect all these things. So you could like have a physical pet thing that you could hold on to with your hands that wirelessly communicates to the screen, and you can see its emotional state up on the screen. That might be fun. I don't know. I'm just throwing out ideas.
Yeah.
Mhm.
That seems complex though.
Well,
I think
you
that'd
know,
be
can
like
build up to
stage
it
3.
slowly.
you know how to do all that, though, right? You know how
Sure.
to get sensors in a mobile package that beam back information to. I mean, that would be the complicated part for anybody else. They'd be
Right.
like, how do I, make my wireless pet detect that it's moving, or if there's a person in front of it? That's really hard. And you're like, that's easy. I've done that.
Mhm.
Yeah, maybe I could do that. But I
Yeah.
think that would still be iteration 3. First
Yeah, I
iteration
mean,
would
you
be
could-
like
Yeah.
text only, like a little zero with a squiggly on its head,
Yep.
Right.
Yeah.
And move it around the screen.
and it would like poop out periods, and I'd feed it commas or something like that. Oh, that'd be so cute. All right.
There you go.
Yep.
Something to work on.
Now you said there were like other tips and such you were gonna.
Oh yeah,
talk
there's
about.
tons of them. Oh, let's see. I made a little game once where there was like asteroids flying across the screen,
Yeah.
and they're all like big O's and little O's and periods and commas and stuff like that.
Yeah.
They're scrolling constantly left.
How do you have them scrolling constantly left?
Well, you basically have an array that
Repeats.
keeps track of all of your currently on-screen objects, right?
Okay.
And it keeps an XY coordinate for all of them.
Okay.
And to scroll in one direction, each iteration you're moving the X negative a certain number,
Mhm.
Depending on how fast it's going.
Mhm.
The more negative, the more fast, because it's gonna bump farther left each turn, right?
Mhm.
Right.
And when it gets below 1, then you give it a new number at a different Y on the other side of the screen, back, setting the X to the maximum again.
Mm.
So, every time an entity gets off to one side of the screen, you're essentially creating a new entity to replace it on the other side of the screen. And then you've got your little spaceship who you can move up and down with the arrow keys to try to dodge the the space debris as it's flying by.
Right.
Real simple.
And that's easily done with the propeller.
Oh yeah, oh yeah.
Oh yeah.
Very easy.
Hmm.
I mean, I was
And
able to do
to
this in like
answer-
1984 with a Commodore 64. I'm sure you could do it.
True.
To answer your earlier question about how complex can the graphics be, it's really dependent on the amount of memory, right? So if you're just using the propeller with its built-in memory, then you're going to be limited by that. So you
Okay.
have the 32K of hub memory and, a little bit in each cog.
Okay.
But, that's why typically on the propeller, they'll use tile drivers to do graphics, because doing a bitmap graphics would require too much memory, like use up all the memory just to have, a byte for each pixel. At any high resolution, they could do it at low res, but if you want to have nice high resolution, then you're going to use up all your memory just to display the screen.
Mm-hmm.
So you use tile driver mode and you make a custom character set with the graphics in tiles, and then it doesn't take up as much memory, right?
Mm-hmm.
So
Now,
you have more memory for your game, and you can still draw something that looks high res in graphics, but it's really a bunch of tiles being used to draw it.
right. Now, if I want to do like make the screen smaller, so I don't want it to use all of my computer screen. I just want it to use, say, like, I don't know, 100 by 100 pixels or whatever.
Well, you can't, it's always going to draw the whole display,
Ah,
but you could just make it not draw anything on the lower portions of it, right? But
So
it's
I-
always going to redraw the whole screen, because that's just the way VGA works.
oh, I see. Okay.
Right.
So
It
even if you
draws-
change from 32 columns to like 10 columns by 10 rows, that won't change a thing?
Well, if you did that, normally what would happen is that it would just make everything bigger, and your 10 columns and 10 rows would just fill up the whole screen.
Ah, I see.
The other thing you could do is you could just draw in only the top 10 by 10 area of the character array, and it would only put stuff in that top corner, and
Right.
then the rest would just be left blank.
Right. Okay, I got it. But I mean, if I'm forced to use the entire screen, I might as well use it then.
Yeah.
Okay.
And you can do different settings to get more or less rows and columns depending on what you want, right?
Mm-hmm.
The size was chosen there based on the built-in font being a particular size, which is 8 by 16, and then the resolution that it was running at is sort of a standard VGA resolution divided by 2, I believe.
Now, in terms of, like, I keep looking at this tile driver code and that propeller beanie, and like, how do I do that in ASCII for the DAT section? Like, if I
Well,
don't
you wouldn't do it like this at all, because this is
tile driver,
actually doing pixels for a tile, right?
right.
Um,
So, like, would I do long and then?
well,
then,
you'd probably just do like a byte, right, with a byte array of characters, kind of like a string,
so how would I type that
if
out?
you-
Like, say my face is, or say my character is the happy face, like the upper up caret underscore up caret, right?
Right.
Now, how would I write that out in the DAT section?
Well, you would just have in the DAT section, you'd put a label on the side, like in TV tech or in VGA text, we had the palette label, right?
Mhm.
And then a byte, and then you can actually put coded strings in the DAT section. So you would just say byte space and then quote upper caret underbar close, upper caret quote, right? And that would be 3 bytes that would be next labeled with the label that you put there. So if you put happy face, right?
Mhm.
Happy face space byte space the quoted string, then you could refer to the happy face label in your code up above, and it would draw that set of characters.
And would I send that out as a string, a decimal,
Yeah,
or
you would send it out as a string.
Okay. All right.
You would treat it just like it was a string in the, like if you do the string command.
Okay. Yeah.
Right? You just don't need to do the string command. You would just say stir and then the label.
And say I wanted to change the face of the character to go from like underscore.
Your palette's going to have more than one preset in it.
Well, I know. That's what I'm saying.
So what you want to do is pick a standard width, right? You're either going to have it 3, 5, 7, etc.
Whatever number.
But not for all of them, right?
All of them have to be the exact same
Why?
width. So that when you print it out, it always comes off your offset so that the center of the face is in the same place.
But,
no matter which preset you pick on your list.
But when the character...
And your preset is starting at the address of the beginning of your byte array.
Mm-hmm.
And if you know how many bytes each preset is in that list, you can jump to them as an offset off of the address of where it starts.
But when the character grows up, it's going to get bigger.
Right, you're going to have faces where it's bigger.
So what you'll do is you'll have a different table that is the bigger version of it, and all of those will be the same size as each other.
Yes.
But so one table will be the little one where they're all 3 characters wide, and then one table will be the bigger one where they're all 5 characters.
And how do I differentiate the tables?
They have a label. So like you have small creature with the table, and then medium creature with a table, and then large creature and a table. And the label is how you refer to them.
So it'd be small creature, happy, space, bite, space, colon,
your string defining what it looks like.
The string
for happy, yeah.
And then I could have also, medium, happy, space, bite, space, and then the size, that medium face. I see.
Right, and you could, and like Whisker was saying a minute ago, you could have more than one. So you could say, small creature happy space bite, and have the happy face, and then you could do a new line and do tab in and just say bite, and then have like the sad face, and then you could refer to the sad face by using the happy face label +3.
Plus 3?
Because the character is 3
characters farther into the array, right?
Oh.
So as long as they're a standard width, you can just stack them all together in one big long string, and you can get the beginning of the string with your label, your at label name, in the case of small, okay? At small, you know that the first 5 are the happy face, the next 5 are the sad face, the next 5 are the hungry face, the next, you've got one for everything. And you can use this trick to also have, your small is only 1 character tall. Your medium might be 2 characters tall. So you've actually got 2 lines that you're reading. You've got medium 1 and medium 2.
Okay.
And you could, you go to position 6 out of each of them to get super happy top, super happy bottom. And then you print them out on 2 lines off your offset of where he's at on the screen. And then, large would be 3 lines or whatever.
I'll be making it easier. They won't be vertically expanding. They'll be horizontally expanding.
Well, it's not that much more difficult to do it, you see.
It's actually pretty easy.
It's pretty simple. So there's no reason not to.
Now, how do I
get the one line working first and, get comfortable with how your table thing, how you want it to work. But once you have a table system in place, it's not hard to add extra lines.
Okay. Now, how would I, make a character change faces? So say I wanted to go from, happy face to sad face, right?
Well, for starters, you would probably have a variable somewhere that would be, the state, the status of your character, right? Or the current state of my creature.
Right.
And, at first, it might just be one variable that's just whether it's happy or sad.
Right.
So it would just be 0 for sad and 1 for happy. And then in the code, you would just decide to print which face based on what that variable equals.
Right.
Right. So that's the most simple one.
Right.
And as you expand it, you'll add more variables for more kinds of state, like hungry, how hungry they are, right? And
How hungry they are plus how tired they are minus how rambunctious they are equals, this. You just create
Crazy
yourself
face.
a little formula to figure out what face goes with which set of
right.
variables. But we are out of time.
Poo.
Well, real quick, the other thing that you
Blue
would have
face?
there is where they're at on the screen. That's part of the state of that particular character.
Yep.
Right.
Their XY location.
Right. Okay.
So anyway, yeah.
Okay.
Alrighty. You guys can find this show every Tuesday at firstspin.tv. We put it up in the evenings. You can automatically download it to your phone, your iTunes, whatever, through the RSS feed on the side of the page. And you can also just click play on the page to listen to it right in your web browser. It works too.
Mhm.
All right, that's it for us for this week. We'll see you guys next week.
Bye.
Bye.